So, remember, in order for triangles to be similar triangles are like enlargements and reductions. That's what similarity means. It's enlargement or reduction. Similar triangles have two basic properties: the corresponding sides We'll start with corresponding angles. Corresponding angles are congruent. Corresponding sides are proportional. Those are the two properties for similar problems, for similar figures. Okay, for not just for similar triangles, similar quadrilateral, similar whatever shapes. Now, some of them got a little bit tricky in the worksheet. Some were not so bad. I know some people had trouble with number 13 on the back there. So let's take a look at that for a second and see how we'd set that up. Remember, when we're setting up similarity, we want to compare, or for sides, we need to set up proportions using corresponding sides. And that's where it can get tricky, figuring out exactly which sides are corresponding. All right. Sorry, I sat down. There they are. I can't find my glasses because they're on top of my head. Good. It's definitely being like a Monday. It's not, but it's being like a Monday. So, we had one that was kind of like this. And then the other one, and here's where it got tricky, is figuring out which went with which. All right? Not the way I drew them, no. But you've got, guys, hey, stop now. All right? We aren't going to be having this constant commenting going on. That's going to end immediately. All right, you've got the picture in front of you with the worksheet. So yours is better than mine is. But you had 35, 35, 30, and unknown. And here I had a 42. And the question mark was over here. That was the side we were looking for. Now, the only thing we could really go with at this point is to find the corresponding sides as best that we can. And it was kind of hard to determine exactly the way this thing was oriented. But it does look like the 42 is the longer side than the question mark side. Based on the picture that I'm looking at here, it looks like 42 is longer than the question mark side. So the 42 must correspond to the 35, because the 35 is longer than the 30. Okay? So the 42 is longer than the X side. And the corresponding opposite sides over here would have to be these two, and it would be the longer one on top. 35 over 30. And that makes sense. Because when we do our cross multiplying, now remember, we set up our proportion because we want to think proportionally. When I cross multiply, I can just go ahead and cross multiply and do this, and we get some really big numbers. Or I could simplify this, because 5 goes into both 35 and 30. I could say 42 over x is 7 over 6. And then it's pretty easy. Oh, that's times 6, right? So it's got to be the equivalent fraction times 6 down here also. So x is going to be 36. So we can kind of use equivalent fractions to do that and simplify our process. If you didn't want to do the equivalent fractions and simplifying, you could just do straight up cross multiplying. You get 42 times 30 equals 35 times x. And and you get some big numbers, but we got a calculator that can handle that too. 42 times 30 is 1260. We divide by 35, and guess what I'm going to get? X is, again, 36. Okay? So either way, we come up with a solution, whether I simplify and do it that way or whether I cross-multiply. But again, the trick when we're setting these things up is to set corresponding sides together. And in that picture, it really isn't crystal clear that the 42 is longer than the X. So that made that one a little bit ambiguous. But for most of our cases, it was pretty clear which is the longer side, which is the shorter side, and how you are to compare them. For 15, for example, it's pretty clear that the 6 corresponds to 15 and the 14 with the unknown. So 6 over 15 equals 14 over X. That one was a lot easier to see, that's all. And on a test, we'll try to give you ones that are a little easier to see, like that. We won't give you ones that are more ambiguous like that. There's one other that people had difficulty with. I think it was 20 or 21. The 21 or 20, I think. So let's look at number 20 real quick. Again, comparing corresponding sides. I had a 40, a 30, and a 36 in the first quadrilateral, and a 30, a 35, and a 2x plus 1. Well, clearly, the 2x plus 1 corresponds with the shortest side, because that's the shortest of our 3 sides, which would be the 30. So 2x plus 1 corresponds to the 30. Now I have to pick one of the pair of corresponding sides. Let's pick the longest ones, if those are corresponding. They are the 42 and the 35. So again, we're just consistent, 35 over 42. Yes, I could flip them both. It could be 30 over 2x plus 1 is 42 over 35. But these two, we have to be consistent. These came from the smaller quadrilateral. These came from the larger one. We have to be consistent that way. Again, I could just cross-multiply it or get some big numbers, or I could reduce before I cross-multiply. Either way, I'm going to have to cross-multiply in this case. I am going to reduce. Remember, I reduced on one side alone. So 2x plus 1 over 30. I can't reduce the 2 and the 30. Remember that from your algebra days. That is not going to reduce because we've got a sum on the top and just a single number on the bottom. I can't cancel parts of polynomials. That's huge. You cannot do that. However, this is just a plain old fraction. We can reduce that. That 7 goes into both of these, so that's 5 over 6. I also can't cancel the 5 and the 6 here. I'm going to multiply them, not cancel them. We reduce on one side by itself. We can cross-multiply. So 5 times 30, or 150, equals 6 times 2x plus 1. And we're going to have to distribute. We've got some algebra work here to do. We subtract our 6. Get 144. Get 12x. Divide by 12. I get x is 12. So we get x is 12, and that's it. We're set. So again, it's some algebra work. You have to be competent with our algebra, but for the most part, it goes pretty smoothly. We're going to look at it more today and other things too, but let's look at how we prove triangles are similar, because that's what we're really interested in. This is what's really important to us. There are going to be 3 ways we're going to learn to prove that triangles are similar. 3 different ways I can do that. The first way is the easiest way. It's called angle-angle similarity. Now, angle-angle-angle didn't work for congruence, did it? That was one of our things that didn't work. We had congruence, we had side angle side, side side side, angle side angle, angle angle side, but angle 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 didn't work for congruence. It does work for similarity. But it's even easier than that. We only need 2 angles. So if 2 angles of one triangle are congruent to 2 angles of another triangle, because remember, corresponding angles have to be congruent. Not proportional. Congruent's a lot easier because that just means same measurement. We only need 2 angles. Why do we only need 2 angles out of the 3 angles of the triangle? Why wouldn't we need that third angle? Because they'd have to be congruent, right? If 2 angles of one triangle are congruent to 2 angles of another triangle, the third angles also have to be congruent. Right? Because the triangles all add to 180. Every last one of them does. We got 2 congruent here and 2 congruent here. The third ones have to still be congruent every time. We already learned that. That's an old theorem. That's third angle theorem. So that's something that's why we only need 2 angles, not 3. So the easiest way to prove that 2 triangles are similar is to show that 2 pairs of corresponding angles are congruent. And remember, when we name them, they have to be named in corresponding order, just like we did with congruence. So if I get triangle ABC is similar to triangle XYZ, that means angle A and angle X are corresponding, B and Y are corresponding, C and Z are corresponding and congruent. It also means we have this proportion. This is kind of a review of stuff we did. That proportion is always true, and again, it's corresponding order. AB corresponds to XY. BC corresponds to YZ, and AC corresponds to XZ, or ZX, however you want to put it. So we get these proportions, and they're all in the similarity statement just like it was before. This is a similarity statement right here. If it asks for a similarity statement, that's what we mean. Triangle ABC is similar to triangle XYZ. If it asks for a statement of proportionality, then this is what they're looking for. Or corresponding parts, however you want to call that. The similarity statement is just triangle ABC similar to triangle XYZ. Now, are the triangles similar? If so, name them in the correct corresponding order. Angle-angle similarity is, like I say, the easiest way to do this. So I look at the picture and say, okay, this angle 55 is definitely congruent to this angle 55. That's like a gimme. We aren't proving it. We're just working through it in our head, though. What other pair of congruent angles do we have? Yeah. There's the V. Vertical angles, yes. The vertical angles right here are congruent, aren't they? Because they're vertical, they have to be. Okay? So, do I have congruent, or do I have similar triangles? Absolutely. They are similar. They are not congruent, but they are similar. And we'd name them. Triangle, I'm going to go A, B, C, is similar to triangle. Notice the similar symbol. Maybe use the triangle symbols. And now we have to be corresponding order. A corresponds to A. That's nice. B corresponds to E. So C must correspond to D. So ABC is similar to triangle AED. And that would be our similarity statement. The reason would be angle, similarity. That's how we know they're similar, because they have 2 pairs of corresponding angles. Would this be similar triangles? Well, this angle V is congruent to itself, right? And that's in both triangles. But this angle 65 and this angle 70. So I don't know. Okay. What if I told you we could switch it off. We could say this angle is 65 and that angle is 70, and then we would, but we don't have enough information to do that yet, do we? We need to have more information in order to make that happen. So, not similar triangles in that case. Now, angle-angle similarity is just one of the 3 ways we have. The other 2 ways we have are called side-side-side similarity and side-angle-side similarity. They're a little bit more complicated because now the corresponding, well, side similarity, there are no angles involved. So there are no congruent angles, we just have proportional sides. Side angle side similarity, again, just like side angle side congruence, it has to be the included angle, the angle between the sides, and the angles have to be congruent, and the sides have to be proportional. Now, when we're using these reasons to show that things are similar, a couple things that are very important. First, we have to use a similarity symbol. Okay? That's what this highlighted box is here. You might want to pay attention to that. When asked for a reason why, you can't just say side, side, side. If you do, side, side, side is a congruence theorem, not a similarity theorem. So we have to add that little symbol, side, 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 similarity, side angle, side, similarity. And then we can just go ahead and see if things are proportional or not. Now, how do I know? It's easy to tell if corresponding angles are congruent, right? I mean, congruence is easy. They have the same measure. How do I know if things are proportional? Well, there are a couple ways of doing it. We could cross-multiply, which works well when I have just two pairs of sides. Or we could reduce and reduce everything to scale factor and see if it comes to the same scale factor, which works better when I have three sides. So here, are these similar triangles? Are A, B, C, and D, E, F similar? Well, they have corresponding right angle, so that angles are congruent. That's nice. We have to see if the sides are proportional. So I set up a proportion. 8 over 12 and 9 over 13.5. Is that a true proportion? We're asking the question. Okay, I put the equal sign there with a question mark because that's what we're asking. Is that a true proportion? And if it's a true proportion, then these are going to be similar triangles by side angle, side similarity. How do we check it? We cross multiply. Now, I'm probably going to need my calculator for that. That's fine. 8 times 13.5 is 108. And we're going to say, is that equal? Whoops. Goodness. Try this again. Is that equal to 9 times 12? 8 times 13.5 is 108. This is also 108. There we go. Yes, they are equal. Therefore, these sides are proportional. Therefore, I could say triangle ABC is similar to triangle DEF by side angle side similarity. So it's kind of like a little bit of mini proof, but more with algebra than with the two column thing. All right? It's kind of like doing proof, but not formally. A little more informal. And don't worry, you'll get a couple days. You'll get basically 3 days of practice on this before. This is the last two things. You've now learned everything. We've now covered everything you need to know. You're going to get like 3 days to practice this before we take a quiz on it. All right? Because it does take a little bit of getting used to, especially coming back after a 2-week layoff. Side can be a little bit more confusing, but it's really not that bad. Again, we set up our proportions, because there are no corresponding congruent angles here. I don't have any congruent angles, because I don't know anything about any of the angles. I just need to know if the sides are proportional. So when I set up my proportion, I got to be careful, shortest side to shortest side. Middle side to middle side. And longest side to longest side. Now, I can't just cross-multiply because there's 3 of them now. If I want to do the cross-multiplying thing, I'd have to first do it with these 2, and then with these 2, and then with the third set of 2, and if all those proportions came up correctly, I'd have to do 3 sets of cross-multiplying. I'd rather not. So instead, what I can do is I can reduce all these fractions to lowest scale factor terms. 8 over 12, well, 4 goes into both those, that's 2 out of 3, 2 over 3. 12 over 18, 6 goes into both of those, that's 2 over 3. 9 over 13.5 is a little trickier to reduce because of the decimal. So here's how we handle that. I multiply top and bottom by 10 to get rid of the decimal. So I'm going to take this 9 over 13.5, it's going to become 90 over 135. And then I'll reduce that. Well, guess what? 45 goes into both of those. Twice here, 3 times here. All 3 of these reduce to the same factor, don't they? If all 3 of them reduce to the same factor, yes, they are proportional. Yes, those are similar triangles. And that would be a proof by side similarity. So triangle ABC, similar to triangle DEF, and the reason is side similarity. So for side, the easiest way is to just reduce the fractions. Now, could we have done that here too? Yeah, instead of cross-multiplying, I could have reduced this to 2/3 and reduced that to 2/3. That would have been sufficient there as well. I don't have to do the cross-multiplying there to show they're similar. I could do the reducing thing as well. So I've got the choice. So those are 3 ways of proving that triangles are similar. Angle-angle similarity, side-side similarity, and side-angle similarity. There's no angle-side similarity, because that would just be angle-angle. Same with angle-angle side, don't need that side. Angle-angle is good enough. Once again, angle side does not work. Sorry? That's not the way it goes. Some of the pictures can be complex. What triangles are similar in this particular figure here? So ABC, the outer triangle, is a right triangle. BDC is a right triangle, and ABD is a right triangle. Because again, we have right angles in here. So that's right angle, that's right angle. Are there similar triangles in that picture? Well, let's kind of break it down a little bit. Okay? All right, I didn't have this one broken up yet. If I take a look at just the outer triangle, sometimes it helps just to redraw. Okay, I have A, B, which is a right angle, and C. If I take a look just at this triangle inside here, I have a right angle, angle C, this is D, and this is B up here. Now this angle C is exactly the same as that angle C right there, isn't it? The triangle on the right and the big triangle, angle C did not change. It's exactly the same. So this angle C corresponds to that angle C. Those are similar triangles. They have 2 angles that are congruent, don't they? They both have a right angle and that angle C. So triangle CBA is similar to triangle CDB. You're saying, wait a minute, how come B isn't with B? Because I'm splitting B up. This angle B is not the same as that angle B. It has the same letter. That's it. I split it up. Okay? We could do the same thing with my third triangle, BDA, because this has a right angle and angle A. So I said for this first one, CBA, so A corresponds to A, B is the right angle, this is ABD. So that would be BDA. Now, like I said, that's kind of complex. That's all twisting it around and flipping it around and everything like that. Some people will look at this instead, the same picture, but instead of trying to do it that way, what they'll do is they'll reorient everything the same way. They'll say, okay, let me reorient everything like this triangle. So I've always got my long leg, short leg, hypotenuse. So that's A, B, D. So I'll reorient this one, I'll rotate it down this way. So it's this acute angle is B, then the right angle is D, and C is up here, and the big outer triangle, the right angle is angle B, the larger angle, I didn't make that really clear that that's the short side. Hold on. Redraw. There we go. The short side is BC, and that's A over there. This is a complex picture, but it's one we will be dealing with a lot next semester. We'll see that picture again. Don't pack up yet. We're not done. See people like starting to make music. Time's up. No, we still got about actually almost 4 minutes. So, relax. So, can we tell if the triangles are similar or not? If so, name it, and state the reason why, showing your work to justify it. For this triangle, I have a right angle, I have a 55 and a 35. Now, first glance, 55 and 35 are not the same. That's true. But they aren't the same angle. If this angle is 55, what does this angle up here have to be? 35. Oh, maybe they are the same. So triangle, and we name it, we go AFB is similar to triangle. A corresponds to C, F corresponds to E, and D. By angle, similarity. That's my reason why. Do I have similar triangles here? Well, I do have the corresponding angle here, right? Angle R is congruent to angle R. That's fine. Actually, I should probably be a little more specific, but we'll just mark it for now. And I say, okay, well, are my sides proportional? Well, remember, I have to compare shorter to shorter and longer to longer, right? So the 6 corresponds to the, which one, the 12 or the 20? 6 goes to the 12, and the 10 goes to the 20. Is that true? And it's real easy to see those both reduced to 1/2. Yes, they are true. So of course, yes, exclamation point says yes. Okay? So 1/2 does equal 1/2. So triangle, now we have to name it, IRB is similar to YRD, and that's side angle side similarity. And this is what we're going to be practicing doing, okay? Looking at stuff like that. Let me get your worksheets for you.